Good morning, mathematicians. It's Wednesday, and we're actually starting with thinking about this multiplication problem and solving it two ways. So here we're going to solve it with the area model, and here we're going to solve it with the standard algorithm. So let's get started. Here we have 57 times 43. Those columns are already labeled for us. So I'm going to start with my 4 times 5 is 20. Now, how many zeros exist outside that basic fact? We've got 1, 2. So I know that 50 times 40 actually equals 2,000. All right, now let's come over here. We have 4 times 7, which is 28. And how many zeros are outside that basic fact? Just 1. Now we have 5 times 3, which is 15. And how many zeros outside the fact? There's 1. And now we have 7 times 3, which is 21. Now, if you can, without making error, sometimes it's a great idea, for example, here, to combine these values over here, if you can do it in your head without making a little mistake. We have 2,000 plus 280, so I can really easily, without making a mistake, just combine those in my head without having to record them both. I can do the same thing with this because I'm looking at 50 plus 21, so I know that I'm looking at 171, right? If there's any question about combining those values in your head, then don't do it. Write it out. You could always just have your four partial products in a row and then add them. But in either case, we're going to arrive at the same answer if we've done them correctly. So we should have 0 plus 1 is 1. 8 plus 7 is 15. Here's my 5. Carry my 1. 1 plus 2 plus 1 is 4. And 2 is simply brought down. So we have our answer here of 2,451. We should find that this leads us to the same place, to the same answer. And we're going to start with the 7 being the center of this multiplication universe. We're ignoring this 5 altogether. That's why we like to call this our diva digit. It's the center of the universe, right now at least. We're going to give it its turn to hang out with the 3 and then to hang out with the 4. The 4 will dethrone it and move over to the 5. So let's get started. 7 times 3 is 21. Here's my 1. Carry my 2. 7 times 4 is 28 plus 2 is 30. So I've written that like this. Now that 7 is no longer the diva, right? We're going to cross it off. We're going to cross off anything that was carried from the 7 because now the 5 is clearly the coolest number. We're going to let it be our diva, and everything is going to center around the 5. But remember, the 5 is actually 5 groups of 10. That's why our answer to that is going to start here. That's why we use what we like to call our golden 0, our magic 0. Really, it's just math. But let's go ahead and move on to the 5 in the tens place. 5 times 3 is 15. Here's my 5. Carry my 1. 5 times 4 is 20 plus 1 is 21. Now I have two different partial products. And when we take a look at these partial products, we have them nice and lined up, don't we? So here we have 1 plus 0 is 1. 0 plus 5 is 5. 3 plus 1 is 4. And 2 is simply brought down. Take note, boys and girls, we have our answer here and our answer here that are the same. Two different strategies, but certainly the same answers that we found. Let's go ahead to some volume questions. Man, this volume question is a little bit different because unlike our problems yesterday, where the volume was labeled, here we're actually going to count the cubes to label the volume. But what I really like about this one is we're still going to be partitioning it. So when I take a look at this, look, if I partition it here, do you see what happens? We don't have a whole prism, right? Because we have a missing structure there. So that's not a great place to divide the prism. But look, if I divide the prism here, or if I divide the prism here, I'm not getting a whole continuous prism. So what could our strategy be? Well, our strategy could be to think about like this particular prism right here that is continuous, and then to look at those other structures down below. Do you see what we're talking about here? Because we have some missing parts here. So let's go ahead and let's start with that. When I take a look at this particular prism, which I'm going to label as prism A I can use the volume formula for. I have a length of 1, 2, 3, 4, right? I have a width of 1, 2, and I have a height of 1, 2, 3. Notice that I really just had to sit and count those cubes in order to get that. Well, I know that that 4 times 2 is 8, and 8 times 3 is 24. So I already know that I'm looking at 24, and I know they're centimeters cubed because of the answer here, right? Already giving us that little part. Now, I know that that is true, but that's not all of it. By far, it's not all of it. I actually see another prism down here that I could use the volume formula on. So I'm going to go ahead and do that. I'm going to call this one B, and then I still have to make sure that I go back and account for this little line of prisms right here. So I can go ahead and do length times width times height here. And many of these are going to be the same. Look, we have 1, 2, 3, 4. So the length measure really is the part that's the same. When I look at the width, I have 1, 2. So this one has a similar width, except it's just shifted backwards, but it's still 2 cubes. This one also is 2 cubes, but they were just shifted back or forward a little bit. B is shifted back a little bit. But the height is also 2 here. The width is 2 and the height is 2. So it's going to be a little bit smaller, isn't it? So here I have a volume of 4 times 2 is 8. 8 times 2 is 16. So I'm looking at 16 cubes in prism B. Now what I want to remember is that I have a singular line of cubes right here. So this singular line of cubes is one in length, one in width, but certainly we need to for one in height, one in length, but the width of it is going to be 4 cubes because we can assume that it goes back. Since everything else is the same length of 4, let's go ahead and account for this being a line of 4 cubes. So in what we could call kind of prism C back there, we have 4 additional cubes, don't we? Those 4 cubes are just in a line back there, and they need to be accounted for as well. So I have 4 cubes from prism C, I have 16 cubes from prism B, and I have 24 cubes from prism A. Well, 16 plus 4 is 20. 20 plus 24 is 44. So as I counted out the cubes, in order to use some formula, but other times, like with Prism C, we just kind of added on those extra cubes. We've arrived at this overall volume of 44 cubes. Let's come down to a question where we have to know how many days there are in May. We just have to have that knowledge for this question. There are 31 days in May. This says Marilyn Monroe rode 83 kilometers every day during the month of May. How many kilometers did she row in total? So, if she rode 83 kilometers over the course of 31 days for every day of May, how many kilometers did she row? We could do this with the area model. We could do it just with some vertical multiplication. Let's go ahead and get started here with the standard algorithm. I know 83 times 1 is going to be 83. So I'm going to write that down below. I'm going to cross off my 1. I'm going to move on to this 3. 3 times 3 is 9, and 3 times 8 is 24. So now we're going to add these together. 3 plus 0 is 3. 8 plus 9 is 17. 1 plus 4 is 5. And I'm going to carry down my 2. So my answer here is 2,573. And I'm going to ask myself now, what is that number representing? Well, that number is representing the kilometers she rode in May, right? So again, boys and girls, if you accidentally did this by 30 or a different number, you may just not have used that fact of 31 days in May. If so, just go ahead and pause the video and try it out on your own and see if you arrive at the correct answer. Our last question for Wednesday says, Plaque Nicholson, the dentist, has a full tube of dental paste, but he needs to use 3/8 of the tube on the first patient, a half on his second patient, and fourth on his third patient. Will he have enough paste? That's the question for us. So what we're going to do is we're going to add these numbers together. And after we add the numbers together, we're going to see if it is less than one whole or equal to one whole. Because if it's equal to one whole or less than one whole, he has enough paste. If it is greater than one whole, nope, he does not have enough, right? Now, yesterday, I think it was yesterday, we did work like this where we had to convert some fractions to get to our common denominators. And we're going to do the same thing here. I see 8 is a great denominator to set because I certainly can this denominator and this denominator into an equivalent fraction with a denominator of 8. So if I want to have 1/2 equals something over 4, I know, or something over 8, I know that 4/8 is the same as 1/2. When in doubt, I could say that 2 times what equals 8? Well, 2 times 4 equals 8. So 1 times 4 equals 4, right? We have to treat those numerators and denominators fairly. We're going to do the same thing here. 4 times what equals 8? Well, 4 times 2 equals 8. So I have to multiply the numerator by 2 as well, and 1 times 2 equals 2. Now we have denominators that are the same. So when we add, we're going to keep our denominator 8. And now we're going to add our numerator. 3 plus 4 is 7, plus 2 more is 9. So we have a numerator of 9, a denominator of 8. Anytime that our numerator is greater than our denominator, we know that 9/8 is greater than 1 whole. So unfortunately, no, he does not have enough. He doesn't have enough pace, and that really was the question that we were seeking to answer. Boys and girls, that finishes out our Wednesday